Hi there, my name is Kevin Cooper. I'm the Dean of Advanced Technology at Indian River State College, and I'm here with a great colleague and friend, James Auld from NextEra Energy, the mother company of Florida Power and Light, and we're here today to talk about industry partnerships. How you doing today, Jim?
Doing great, Dr. Cooper. Good to be here.
So Jim, we've been doing this for a very long time. Tell us a little about what makes a successful industry partnership and the genesis of this interaction.
Well, in a word, Dr. Cooper, collaboration is imperative. But before we get into that, I'd like to go back and give a little history lesson of the Florida Power and Light Indian River State College relationship. The relationship goes back decades, but I would like to start in 2005. That's when I became involved. In 2005, we looked out at the horizon of our workforce and we saw a lot of gray hair staring back at us. We knew we needed to do something because we had an aging workforce. So we reached out to our go-to partner, Indian River State College, and we launched an electrical power technology program. And it trained highly skilled and well-educated electrical maintenance technicians, instrumentation and control technicians, and mechanical maintenance technicians. But what has made this program sustainable and successful is the collaboration and the commitment that it takes. It wasn't just simply Florida Power and Light works with IRSC, then IRSC launches the program. We've had to be with them every step of the way, particularly in this advancing technology world that we live in. So Kevin, what technology have you seen advance since we started our program?
So it's a really good question because we've gone through generations of technologies over the years, and for everyone at home, 2005 to today, we've really gone through a digital revolution. So when we started training with Florida Power and Light, we looked more old school. We were talking about maintenance on equipment, routine maintenance, routine repair, but our students actually had to come into the 21st century and learn data analytics. They had to learn how to embed old analog systems with digital systems. They had to learn trigonometry along the way. They had to learn how sine waves work, and they had to learn all these things to transition from a 1990s car mechanic to a 2021 car mechanic, in essence, where the equipment tells you if it's working or not. So, and what's really been nice about what you guys have done with us is you've taught us. We actually haven't always had these skill sets. So you brought in the subject matter experts, you brought in other people, you bought us equipment, you sent us to training to really get us to stay up to speed. And that's probably one of the challenges that exists in academics. We don't always have all the resources, and you need workers, but you understand that we need support to get to where the training needs to be. So does that answer your question a little bit?
Yes, it does. Yeah. And you mentioned trigonometry, and it raises an interesting point. Mathematics is always a challenge when you're ramping up a technical workforce. To overcome some of the challenges faced with mathematics, what did you do?
So it's another good question, and he's leading me to a really successful program we've had in conjunction with the National Science Foundation that you really helped steer. So one of the challenges we've had over the years in mathematics specifically is enrollment in our programs has been predominantly white and male over the years. And when we looked out with the help of NextEra, we actually do aptitude testing. It's called a MOS test, right, at the front end, where we test all sorts of people to get into the program. And it turned out there was no discrepancy between any demographic and aptitude. There was an aptitude for Hispanic, black, white equally, but there was a lack in the math abilities in the other demographics, specifically in African American demographics. And so we worked with you, which was super successful, in redesigning math. So no longer making math a barrier to entry. If someone didn't have college algebra, you actually brought subject matter experts into our classrooms that said, hey, in a nuclear world, you don't understand X, Y, Z, but we're going to contextualize it for you. We're going to make it relevant. And by the time you graduate, you're going to understand it. And we were able to take students then that didn't have the math and put them in. And we've actually, and you saw, a 2008 graduating class was predominantly white. Now we're up to 50% minorities in all these classes from working with you, contextualizing it and making it relevant for the students. So thank you, Jim.
It's a great program, and it's recognized nationally as a best practice. So kudos to that, Dr. Cooper. You also mentioned data analytics. This is so important in our industry. And one area I'd like us to talk about a wee bit is supervisory controls and data acquisition, SCADA for short. In our industry, SCADA drives the where, when, and how maintenance is conducted. So Kevin, what are you doing to advance SCADA in your program?
So again, this is another example of a good partnership. For those at home, NextEra is a huge corporation. It is actually worth more than any other energy company in the world now, and they have facilities in how many states around the nation?
43.
43 states where they're recruiting workforce, and 43 states, and within Florida they have 10,000 plus employees. So from that perspective, you guys introduced us to what some of the best people in the world were doing in SCADA, which supervisory control, which was the University of Wisconsin-Madison, and you helped us form a partnership with them where we were building labs. You know, it was very engineering, high-tech, industry-oriented, and you helped us bring it back down to the technician level and then scale it up across the nation technician-wise. So what we are doing is taking it and simplifying it, making it relevant for technicians, and building SCADA trainers for colleges and high schools around the country so folks can get familiar with what SCADA is. And you've been super generous there as well, providing equipment, expertise, and introductions. So like you said, one of the very valuable things about any industry partnerships is I listen to you when we have to be dynamic. You listen to me with what challenges we have. So can you talk about some of the other dynamic changes we've made since we've gone, like we started primarily in like a nuclear world, and quite frankly, you saturate a nuclear market real quickly. How did you bring in other divisions of your company? How did you introduce them to us and so forth?
Great.
Yeah.
It's a great question. The building on the success of the program that we launched that specifically targeted the nuclear industry, our other divisions, power gen, which is the fossil side, natural gas, also our solar and our wind sides, in our transmission side, a lot of line workers are actually coming out of here. They saw the success of our program and they wanted in on the action. So what we did is we rolled up our sleeves and we looked at the curriculum and we made tweaks so that it could serve a much broader audience. Now, I say this to emphasize just how important the relationship really is, because as soon as the ink started to dry on the curriculum when we first developed it, we had to modify it. We have had to change it. Technology is emerging and expanding so rapidly, it's required us to do that. When I started working with IRSC back in 2006, there were specifically 3 pipelines that we were looking at. One was the electrical, one was the mechanical, and the other was instrumentation and controls. Fast forward to today, a modern technician is all of the above. They need skill sets in all of those. And it's the result of automation. Our pumps and valves and so forth now run and operate on the SCADA that we talked about a little while ago. So the technicians needed to maintain all that equipment have to have all these super skills. And a perfect example of that is, not too far from here, is the most state-of-the-art power plant in the entire world. It's called the Okeechobee Fossil Plant. It's a natural gas plant. It's a combined cycle, a very complicated process. And it's also complemented with solar. A really cool plant. The vast majority of the technicians that work in that plant are graduates of IRSC, and they're known as shift techs. So in short, to answer your question, we've had to continually check and adjust to meet the needs for the employment needs and the technological advancements and so forth.
I actually want to add a little to that. So when Jim came to me, and this is very important for any industry partnership, he came to me and said, we had to add this class, and this class. We have a mature, trusting relationship where I said, we really can't do that. There's accreditation issues. You can't add credit. You can't do these other things in academic space. And we had an honest conversation, and he said, what can you do? And what we said is we can add voluntary courses and send them to line school and ask them if they'd like to work at this most modern plant, if they would take trig, if they would take some rigging and lifting courses and some other courses. And students that really wanted to get ahead and go into this field did it voluntary, and you were able to hire them. But you understood from the get-go that there's limitations within academic space, there's limitations, and you've been very flexible along the way to adjust with us and understand the speed. And that's a challenge that I'll ask you about, because you work with colleges all across the country. How can colleges match the speed of technology, and how can not only just technology, but industry as well? You know, like Elon Musk says, the speed of now, you know, and academics deals with curriculum committee, accreditation, all these other legacy issues. What are the models you've seen that work that help academics match industry speed?
Key to success, and it's absolutely paramount, is that collaboration between academia and the academic institution. Mm-hmm. Because it's the insight and first-hand knowledge that the industry brings to the academic partner, so that the academic partner can then understand and appreciate the rapidly advancing technology. See, we ask a lot of our technical partners. We say to them, we need you to keep your finger on the pulse of emerging and advancing technology, and we need you to train and educate to that emerging and advancing technology. Very, very challenging, right? Because the technology it needs and so forth is absolutely demanding. So it goes back to where we started this conversation, Dr. Cooper. It's the collaboration. To be successful, you have to have academic partner and industry partner working collaboratively. And that doesn't mean once a year you get together and the academic partner talks about all the great things they're doing. That's not an advisory committee meeting. An advisory committee meeting involves an academic partner listening to the industry partner so that the academic partner can appreciate the emerging issues and the challenges that they're facing with keeping up with emerging technology. So let's follow up with this because it's a great point. Where are you seeing your biggest challenge in this technologically advancing energy world that we're living in?
So there's two challenges. One is we always have the challenge of the soft skill set. So, and you always have the challenges. You can get technically sound people, but they're less and less prone to report writing, technical writing, communications. And so we're constantly working on that challenge. So the technology side. But the other challenge is, and I think you see it across the nation right now, is just really an enrollment in these programs, in these STEM programs, very high technology programs. So, there's a lot of models and a lot of things we do to eliminate barriers like math and recruit into other pipelines that we try to do to address this enrollment. But it's the support of someone like you who really comes to the table, and any industry partner understands that if you're having workforce problems getting people in your door, the local community college is also having workforce problems. Mm-hmm. So bringing you in and talking about the careers and the salaries and everything really helps scale those programs. And I would recommend that to anyone in the nation in terms of when you're going to recruit, have that partner at the table. Mm-hmm. So I'll throw the question straight back at you though. From a 21st century perspective, these folks are asking, and I'm really thinking of it from you're actually shutting down some coal plants across the nation and you're retraining workers. Talk a little bit about that challenge it has of what it talks to for upskilling or retraining or rehoming workers, mm-hmm. workers that have been in the same field for 10, 15 years. What is it that you're doing to help those people get employed?
Right. Mm-hmm. So yeah, this is a significant national phenomenon mm-hmm. where fossil plants are reaching the end of their commercial life, and the lost energy is being replaced with more modern power, be it renewable, be it state-of-the-art gas or what have you, or even what's emerging now in hydrogen and so forth. So reskilling that existing workforce is critical. So one of the things that's a hot initiative now are these STW, straight to work initiatives. NextEra Energy, Florida Power and Light is deeply involved in supporting those to train displaced workers or communities impacted by the closures of plants to give them an opportunity to reskill, retrain, and so forth. So Dr. Cooper is deeply involved in a program supported by the National Science Foundation that's actually helping in this area. It's called Project Vision. Can you take just a quick minute and discuss that project?
Thank you for the intro. So Project Vision, like he said, is supported by National Science Foundation and helps community colleges with STEM ideation across the nation. If they have challenges for getting folks back to work in various fields, or they have an incoming industry, how does it tie to their academic, strategic, facility master plan? How does it tie to the industry partners, and how do you get people back to work quickly? So, and for instance, we're working with some schools out west that are doing a lot of wind work with y'all. Mm-hmm. And so just to follow up on that question, what do you see a 21st century energy technician looking like? You started with the mechanical, the operations, the electrical, and so forth, but 21st century, and I'm leading the question, really had to know a little bit about fossil generation, a little bit about solar, a little bit about storage. Yeah. And you really, all these schools that are interested in energy really need to redefine their degree to take aspects of all those. Do I have it correct? That
is absolutely correct. Mm-hmm. And let me answer that by giving an example. When NextEra Energy first got into wind energy 20 years ago, wind turbines were big mechanical things on a stick. We would go to the Jiffy Lube or the Pep Boys, and we would say to folks that change oil, how would you like to come and change oil in our gearboxes? Basically, that was the skill set to be a wind technician. Fast forward to today. A wind turbine is a compound complex power plant on a stick, requiring advanced skills and electrical, mechanical, instrumentation and controls, networking, and so forth. So now that training is absolutely critical and imperative. It's an amazing phenomenon, the time that we live in. We have technicians in the field that are working on these things, and in real time communicating back to our headquarters with engineers, doing in real time troubleshooting, coming up with solutions and so forth, using the data analytics and so forth. Historically, maintenance was a time-based phenomenon, as you know, Dr. Cooper. It's June, it must be time to change the oil in the gearbox. Fast forward, then with analytics, we got into predictive analytics. Well, or condition-based analytics, I should say. Condition-based maintenance says, we know that the analytics say there's a condition, so we need to change the oil. For example, there's foreign material in it, the viscosity's breaking down, or what have you. Now, fast forward to where we are and where we're going. Predictive analytics. So we know we have a condition, right? Predictive analytics says to us, well, we know you need to do the maintenance, but when do you need to do the maintenance? So now we're able to check and adjust and time when we're going to send those technicians and engineers into the field to make those repairs. So keeping up with all of that advancing technology is critical. The data analytics out there is unbelievable. We have so much data coming in that humans can't possibly ferret through it. We have to have machine learning. We have to have artificial intelligence to handle all this data. Someone once said that if you're asked what career will get your child from start to finish in life, data analytics. It's where it's now and it's the future. But we also have to be cognizant of the retooling, as we mentioned, the quick straight to work initiatives, all of these things. There's so many wonderful things that are emerging, the technology, the advancements. It's a great time to be involved, isn't it?
Yeah.
And now we have the hydrogen entering the picture. I'm an old man. I can see the end game, retirement coming. I was in a presentation recently about hydrogen, and I got so excited, I said, I may have to postpone retirement because I want in on this action.
So in essence, to add to what you're saying, you have wind, which is a complex being, but almost every solar field you're building in the future has some sort of generation associated with it, and storage, which is hydrogen or lithium-ion batteries. And so even a solar technician now needs to know solar installation, generation, and storage,
yes.
And it's to maintain the grid, it's to offset peak power, it's to do all these things. But just to come full circle with everything you said, you discussed the importance of math over and over, which is data analytics, which is now trig, because you have to understand the electric signals that produce the predictive analytics, and algebra, because you have to understand data science. You said supervisory control, which tells you everything about it. And you said this overwhelming technician that needs to know all these fields. And so, like you said, it produces an exciting time for the next 20 years of energy generation. So what are your closing thoughts from here?
Well, it's an exciting time. We have rapidly advancing technology, as we've discussed today. I'm really excited and happy to be working with Indian River State College and our other academic partners across the country as we're moving from these, as I mentioned earlier, the sort of classic defined technician roles to more combined roles such as mechatronics. In renewable energy, we're seeing the phenomenon going to what are now known as renewable energy technicians. This is a combination of wind, solar, and storage. We didn't talk a lot about storage. That's a whole nother 2-hour discussion. That's very exciting for another day. It's a great time, Kevin, and it's a great time to be collaborating and working together.
So in closing, I can't agree more. So you broke down these silos. You have renewable, you have sustainable, you have energy. They're kind of all together now. And the other thing that I would say as my closing thought is you've broken down the silos of working with a partner. You've actually introduced us to all your vendors and your contractors. And so what makes a sustainable program is having an alpha partner who's so giving like NextEra, but having all these beta partners like Concord, like Siemens, like Westinghouse, like GE, that actually add to the mix, and so that your entire students always, because hiring comes and goes in waves, and so you were very kind to add all these other partners to the mix as well. So my closing thought is, really it's just breaking down the barriers and the silos and not having verticals and having everyone at the table. So thank you so much for that.
And you know, in my final comment, when I'm asked about the relationship with Indian River State College that we have, I always describe it as a series of valves. We are so able to open and close valves based on the needs. We can check and adjust so rapidly. Unlike other colleges across the country that I work with, that the bureaucracy doesn't allow for these quick adjustments. It's really commendable how you, Dr. Cooper, and IRSC are able to check and adjust at a rapid speed. It's truly remarkable. It's been a great partnership.
Well, thank you, Jim.